it all started with the idea of the parish council wanting ideas to celebrate the millennium. And I was interested in getting an idea of how big the solar system was at the time. And also, I've been reading about how ancient civilizations had their monuments to mark points in time. I thought, wouldn't it be marvellous if we could put a scale model of the solar system in this village, where everything was exact, and in the position with the planets as they were on Millennium Night. So that's how it started. Each one of these is going to be buried into the ground to about there, and then on the top of each of these pillars there's a slight recess. You'll have a disc with the planet engraved on it, but there's a special one, and this dome here, which is meant to represent the sun, to one in 5 billion. The very first thing we had to do was to set out Mars, which is the one down there, which is between the two football pitches, and it was that was fixed because of the safety. Then we worked back from there to the sun pillar, and once we've got the sun pillar positioned, then everything else follows. Has to be 32 metres. Mars over there, Mercury there, Earth over there, Venus over there, and then Jupiter is just beyond the garage over there.
This point here is known as the first point of Aries, and it decides where the stars are measured from. And we work from 0 degrees or 0 hours in an anti-clockwise direction around here. Using two methods. One is obviously the transit of the sun at midday, according to the sun that is, not the time. And the other one was using a map and compass. When the sun is at its highest point in the sky at noon, and because we've got British Summer Time, it has to be just after 1 o'clock.
2 minutes and 25 seconds.
Let's go up there now.
Yes, it's
slightly.
It's not bad at all.
Dig this out. We can't have a leaning.
We got a over it or a good pig.
There we go. Well, I wonder when they'll be discovered, if ever. Yeah.
Yep, right, okay, you let go then. Go on in. Twice the blink. Where's the insert? That's where you want it, Dave.
chairman of the council.
It's very appropriate.
Yes. Okay. Don't actually polish your face.
Okay. Connie and Rachel. I haven't seen Rachel.
No, I haven't seen
No, Rachel. No, she's not coming. Rachel and Zoe. So she phones Trisha on Neptune when the sign is given. She won't know the number, so that's it.
Okay, got it.
All right? Good. And have you got Astrid's number for me?
The 1 to 3rd one. Yeah, it was the one that was on the ground. Yeah, 6 miles, yeah.
She'll be at Venus all by herself, or you can wave to Mars and Kirsty will be by herself. All right? So you'll be looking after the cubs. Okay?
Okay.
The closer ones will be with Pauline and the cubs, and the far-flung ones you'll go off with the adult who's taking you. And the 4 staying at the base are Astrid, Emily, Louise and Gemma. Good. We'll see you all for photographs at the end. Gemma, it's you I need to see, I think. Because you're going to be at the base, and you need to tell Astrid Trisha's number. Is that right? Have I got that right?
Yes.
Oh, cool!
Are we crossing the road? Okay.
And all members?
No.
I've got particular pleasure in introducing Thomas and Councillor Barry Keenan behind me. Councillor Barry Keenan's the tall one, who conceived and enabled this project. It was not straightforward, but it's now complete, except for Pluto, who could not be taken along a footpath because of foot and mouth restrictions. We corresponded with a great many people about this project. One was Patrick Moore. He replied that unfortunately he was laid low and could not be here, but he wished us well and reminded us that one of our leading astronomers lives in Sevenoaks. So, ladies and gentlemen, I have the pleasure of introducing Commander Hatfield, our distinguished local astronomer. Would you do what I cannot, which is to put this project into perspective and declare it open for us?
Thank you, Mr. Chairman. I'm going to cheat a bit because I want you to see how big the sun is. So I'm going to unveil it and then reveil it. That's the sun. Can you see on my badge here, little ball bearing? That's the Earth, on the same scale as the sun. And the sun is 93 million miles away. The Earth is over there by the blue balloons. And the difference in distance between the Earth and Mars is about 40 million miles. So that if this evening at about 10 o'clock you look up there in the sky, you'll see Mars. And it's as close to us as it will be for some years. And this may give you some idea of the real sizeness, so to speak, of the solar system. This is the size of the Earth. This is the size of Jupiter, smaller than a squash ball. And you can get all the other planets inside Jupiter with some room to spare. Saturn is in the doctor's courtyard, front garden, sorry. Uranus, the next one out, is over here at a distance of, doesn't matter. But what I really want to tell you is that Pluto is way up over there, the third hedge up, I think it is, and is 983 meters away. That's nearly a kilometer on this scale. The space Jupiter on Mars and Jupiter is occupied by what are known as the minor planets. And on the scale of our little model here, they would be specks of sand or specks of dust. Hundreds of thousands of them, if not millions. Fortunately, their orbits very rarely come anywhere near us on the Earth. The light from the sun to the Earth takes 8 minutes. So if you look at the sun, that happened up there 8 minutes ago. To Mars at the moment, to us, 3 minutes worth. Not very much at all. Jupiter, light from Jupiter, 40 minutes. Imagine sending a astronaut to Jupiter. You'll send a message off, 40 minutes later he'll get it. And he'll say, sorry, I couldn't understand what you said. And 40 minutes later you'll understand that he's in a fix. And 40 minutes later he'll have crashed. The light from Pluto, over here, on this scale, in the real world, takes 5 hours to reach us. And that's a long time, you think. And outside Pluto, heaven only knows what's there. This gives me an idea of the size of the universe that we live in. And I come down to Earth with a bump, watching over there at the rain approaching rapidly. So I'm going to shut up, and it gives me great pleasure to unveil his nibs, the sun. You'll see up there, there are not only the sun, but there are flares coming out of him and prominences. So there is the sun. And you'll see your face.
And we are now going to release balloons in sequence from the various planets, starting first of all with Mercury. Mercury, release your balloons. Venus, release your balloons. Earth, release your balloons. Mars, over there in the west. Release your balloons, well done.
You'll dry out.
Can you hear me? Release your balloons. Are you receiving me, Saturn? Let go the rocket.
He's there, look.
Uranus, let go the rocket. Neptune, let go the rocket. Pluto, let go the rocket. They're communicating by mobile phone. Right, there we are. Well done, Pluto, well done. Let's see whether we can see Pluto balloons go up. Yes, you can see them. Just below the hill. Thank you very much. Do start to look round the solar system. It's quite a big place.
Yeah, Pluto went off in the end, but it's a long way away, so it took a bit of time.
We're actually standing on Mars.
Who's that?
you want me to be? David Seeley has a son.
So the idea is this sets up the positions of all the planets, and on the red here we have Venus, which is over there, Mercury, which is there, Mars, which is there, and Earth, which is over there. And then once I've set this up, then I can add any other measurements, and I've got the markings here that I can check in another way the orbit of Mercury.
Have a little look closely on this, see what you do.
5.81 meters away from here. The idea of this is that we're taking the measurement from the outside, but the whole thing is 400 millimeters across, so we're taking up that 20 millimeters.
Ah, yes.
All right.
Yes.
So now, okay. Now we want this to be 5.18 meters out. So that's 5 meters. 80.
Sure, that's it. Take my hand away now.
Right. We bring that side.
See?
So this diagram is set up in order to give the position of the planets on any given day, and here we have the 30th of September 09, and I get this piece of paper off the net, and then I mark up the lines which show where the planets are, put it on top of the sun pillar in the correct way, and then use this to direct Audrey into the correct place on the orbit. There, over there, is Mars. Quite nearby is Mercury. Over there is Venus, the yellow. And then back over there is Earth. So that's how we set up the markers for any given day, and I can do it to roughly within a few hours of the correct time.
That's it. So further on. Stop by your just behind, just between your feet.
So that's the one, similar, identical one as to Sydney.
I see.
And Los Angeles has got their own version. They've got a little bar.
Great.
Sorry, first of all to Saturn.
Yeah.
Then to Uranus.
Yeah.
To Neptune.
Yeah.
And then we'll come round to a viewpoint just here.
I see.
Where we can look back to the recreation.
I see.
There you go. This is the model at Los Angeles. Please visit Oxford, England.
Yes, I see. Yeah.
I'm afraid it's fixed. Well, now, Fergus Walsh used this to illustrate where Quawa was. And he walked from the Earth to here,
yes.
And then he went out into the field behind you,
yes.
And waved a flag to say, this is where Quawa was, outside the orbit of Pluto.
Yep.
Now, we've got Mars, you can't see it because it's a ground level,
yes.
between 2 football pitches. Yep. We had to do that. And then we have Earth over there.
I see.
Now, other things that I've got here, with I've mown out the various orbits of the planets of this year. This one is done quite accurately, and I've marked in where 10 days motion is. Yes, so that's where the Earth is. That's where Mercury is.
Yes.
Now, if you'd have come at 6 o'clock, it would have been about 4 meters to the left. 4 centimeters to the left.
Fair enough.
And then we have Mars is out over there. And I thought what was quite interesting about that, there you have the Earth there, there you have Mars, and then Earth is just a little bit beyond where Beagle was launched. And the two will move together, and Mars will be out roughly there when it lands, but Earth is going to be sort of in that position there. Well, isn't there going to be a problem of communication after in the next few months, because you'll have Mars there, Earth there, with the sun in between? No problem.
Plenty of problems, will it? You're bound to. They might relay via space probe, but the actual restriction is bound to come off. Right. But these one of the stationary probes might do it.
Oh right. So there could be a little bit of problem. I mean, I wouldn't have thought about that, but for this model.
Well, it's definitely a problem there, but it's not a serious one. They'll get around it.
Yes. Yes. Right. Now, should we just walk to Mercury?
Okay.
Each of these discs has an arrow pointing to the sun. I'm experimenting with.
Obviously done with immense care. That's totally accurate.
Yes. Yes, we specified to the people who made these that they should be exactly accurate.
Where were they made?
Well, Dartford, wasn't it? Dartford engraved.
No, the steel was stainless steel was purchased at Seal,
yes.
And Able Engraving near Dorking did the engraving for us.
Very well done.
And then the pillars were...
These were in East Sussex,
yes.
East Sussex.
Have you you've seen...
I get the idea now, yes.
Yes, all right, so I think what we'll next do, we'll go over to Jupiter,
right,
which is in the corner there. View of Jupiter as seen from Earth,
yes,
rather than from the top, because I think people sort of recognise that. I didn't put the Great Red Spot in because I don't think it was visible at that day.
It's not always there anyway. I mean,
no.
It disappears again.
Oh right.
It was not there. It does disappear.
But that's how I see the colours through my telescope. I don't know whether that's right or not.
Well, I haven't got their ideas, but for me it's yellow.
Is it more yellow, is it?
More yellow, yes.
Right. Very happy to have it here. And each one of these has now got
It's fine. It shows what it's meant to show.
Yes. And again, it's the view that one had from the Earth instead of the top.
And to get there, we go right into Pluto feeling. We go through the with the correct.
Oh right. So how many miles is it outside the orbit of Pluto?
Well, we don't quite know, but certainly it is very near Pluto.
Right. Don't you think it should be counted as a planet?
We all thought so.
But the way that it interacts with the orbit of Neptune.
We thought we went so well. So very well. We like to keep it as a planet.
Right.
Because my old friend tried Tom Borton.
Yes. So that was remarkable, wasn't it? What a bit of work to find that.
He very quick to do. He's dependent. And the interesting thing is, you know, he works on lower calculations.
Yes.
And pretty accurate.
Yeah.
But Pluto is so small in the main method, it could not produce those calculations.
Right.
Either it was sheer luck, or else the real thing's out there.
Right. Well,
and it's X.
Well, we'll go just outside where planet X is.
Okay, we'll go.
Where is Pluto? See it? Yeah. Now you see there's a gap between the two near, and in the distance there's a darker
I see that.
and just very slightly to its right.
Got it.
There's just the top of Pluto.
Got it.
So that gives you an idea. So we're about 4.5 light hours away from there, and my own part, I think this view back to there.
I agree.
All right.
Still, and in the winter you can see it back.
That's right,
So there we are.
Most impressive.
So I think you deserve to get back.
Most impressive. Most impressive.
Talk a little bit about what your impression is of what you've seen today.
I think it's very good indeed. It sets out to show the vast scale of the solar system, and it's done that very well. So I think it's a very educational thing, and most impressive. Ought to learn with great care, because everything is deadly accurate.
Can you compare it perhaps to other models you've seen?
I haven't seen one as good as this, frankly. I doubt if there was one, certainly not in England. I don't think so.
What sort of purpose do you think these types of models serve? Perhaps you can address the kind of educational aspects and the enlightenment it throws upon all of us.
It brings home, I think, how small the Earth really is and how lucky we are to be in this particular position. After all, see our Earth in the recreation field, go right out to Jupiter and Saturn, right out to Neptune. It does show how insignificant we are, and people don't really realise that. It seemed to me to be strangely accurate. They've taken the greatest care. In the recreation field, it's deadly accurate, of course. Going out to Neptune, Uranus and Neptune, again within a few feet. It must have taken immense care and very careful measurement to make that so.
Could you give our listeners a kind of physical description of the tour we've just been on, just in your own words?
Well, we begin with the Sun in the recreation ground, and everything is to scale here. Begin with the Sun, and there we have the orbits of the 4 inner planets, Mercury, Venus, Orion, and Mars. Then, right at the edge of the ground, we come to Jupiter. It shows how far away Jupiter is. But then, Saturn must be further out still, so we can't see the recreation ground. You don't ever get into the car then, go up to surgery. And then the last 2 journeys, Uranus and Neptune, they take some time. And you realise the vast scale of the solar system, which so many people don't appreciate. Something most unusual, we use great credit to the area, and great credit to those who designed and built it. It must take a lot of doing.
Thanks ever so much. Thank you, Patrick. Very much appreciate your time.
I do it also.
Finally tonight, how do you fit the entire solar system into a village in Kent?
Sounds a little ambitious, but that's exactly what retired teacher David Thomas has done, and he does not intend to stop there, as Damon Green explains.
Otford, the final frontier, because the small Kentish village by the M25 is also home to the world's biggest and most accurate scale map of the solar system. So there.
This is the first time, so far as we know, where a point in time has been defined by the positions of the planets. The first time, humans have ever done it.
Already a bit of a hit in a pretty village where the only other astronomical thing is the price of the houses. The map uses half-ton concrete pillars to show the position of the planets. Its creator compares it modestly to the pyramids of Egypt.
With the positions of these 2 moons on here, the moon on Earth, one can work out in 1,000 years' time, if you understand astronomy, when we celebrated the millennium to within 7 minutes, which I think is quite incredible.
In Otford, men are from Mars, women are from the hedge by the corner of the cricket field, and a stroll at 4 times the speed of light takes you to Saturn, handy for the doctors.
The intention is 1,000 years, that they will be here for the next millennium. I don't think that's unreasonable. The church just over there is 1,000 years old. It's had maintenance, but this will require less maintenance.
From Saturn, a 434 bus will take you to the furthest reaches of space, though it's a brave astronaut who'd ask for a ticket to Uranus. At the edge of the village, the solar system stops, because if they had wanted to show the position of the nearest star to Otford, they'd have had to put the plinth somewhere in Los Angeles. At the planet Neptune, this is Damon Green for London Tonight.
Excellent.
Beam him up, Scotty.
Good night.
Good night.
Now, it's the most significant discovery in our solar system for more than 70 years, according to the experts. Astronomers in America say they've discovered a previously unknown icy world some 4 billion miles from Earth. It's the first to be discovered since Pluto was spotted in the 1930s. Fergus Walsh has been finding out much more for us.
Deep space may look crowded, but discoveries on this scale are rare. And it's this tiny speck that's got astronomers so excited. They've called it Quaoar, a frozen world at the very limits of our solar system. And this is what they think Quaoar looks like, a mass of ice and rock. Now, to give you some idea of just how far away Quaoar is, we've come to the village of Otford in Kent, where they built this scale model of the solar system. This pillar here represents the Earth. The one down there with the silver ball on top is the Sun. It's 90 feet away, but in reality, in space, 90 million miles. The Sun here, built to scale, is of course the heart of our solar system. But if you want to know how far Quaoar is, just keep your eyes on the fields in the distance. And way over here, more than a mile away, is Quaoar. In reality, it's 4 billion miles away, the furthest object ever found in our solar system. The big question now, have we found the 10th planet of the solar system? To be a planet, it's got to be, well, big and orbit the Sun. Here's the Earth and its moon, dwarfing the smallest planet, Pluto. The trouble is, Quaoar is even smaller, just 800 miles across, so it probably won't qualify.
I think the purists would say it isn't a planet, and the same purists have argued for some time that Pluto is also not a planet, and I'm sure this discovery will reopen the whole debate.
Planet or not, astronomers say Quaoar is an important find, and there may be lots more just like it waiting to be discovered. Fergus Walsh, BBC News.